Hello, Math 1 students. Today we're going to go over a lot of vocabulary for the next unit that is critical for understanding the directions and when a teacher is talking about something in class, knowing what they're referring to anytime um, you you hear the word, right? So first off, the first one is when we talk about a term um, in algebra, right? A term is basically a coefficient linked to some variable expression, okay? Now with it, you would look at 3x would be considered a term, right? Where 3 is your coefficient, right? And x would be your variable expression, okay? Another example, if I have like 6x squared, or say negative 6x squared, negative 6 is my coefficient. X squared would be my variable expression. Okay? So a coefficient, a term is a coefficient and or variables linked by, and in this case, multiplication. All right, if you look here, that negative 6 times x to the second tells us that they're linked by multiplication. Now, a polynomial is a collection of terms, right? All right, that are linked by addition and or subtraction. Okay? So an example of a polynomial would be something like 3x to the second plus 6x minus 5. And what you have to understand is this polynomial, right, has 3 terms. Okay? If I give you another one, such as 6x minus 2, right? This is a polynomial with 2 terms. Okay? Now, here's the thing. In math, right, we have 3 common polynomials we come across, with a certain number of terms each time. And we have specific names for them. So any polynomial with just one term would be considered a monomial. So a monomial is a polynomial with one term. So 6x would be a monomial. 8x would be a monomial. Negative 4 would be an example of a monomial. Each of these polynomials has one term and one term only. If you think about it, mono is a prefix for 1. Binomial, where bi is the prefix for 2. And binomial is a polynomial with 2 terms, such as 3x minus 1. If I look, here's one term, here's 2 terms. That's considered a binomial. Another example would be, let's say 6x to the second minus 5. Again, has 2 terms, considered a binomial. A trinomial, tri is a prefix for 3, so it's a polynomial with 3 terms. And an example of this would be 6x squared plus 9x minus 5. Okay, so if I look, there are 3 terms in that example. So if we had to take the first one and determine the name by the number of terms, right? This first one has how many terms? This has 3 terms, therefore it is a trinomial. The second one has 4 terms, right? Anything above 3, we just say it's a polynomial. 2 terms, right? That's a binomial. And 1 term, this would be a monomial. Okay? So now, the second part is in algebra, right? We like to write all of our expressions in what we call standard form. And this is when a polynomial is written in descending exponential order, meaning we go from the highest exponent on the variable expression to the lowest. So when I look at this, 3x to the second plus 6x minus 5, right? That would be in standard form, because if I look at my exponents, x to the second, x to the first, x to the 0, right? If it's just this, you'll find out in a minute, is called a constant, meaning it has no, right? It has no exponent, but we could consider that to be the same as 5x to the 0, which is the same as 5. So the exponent is technically 0, but we just write it as 5. Okay, another example would be something like 6x to the fourth minus 5x to the third plus 6x squared minus 2x plus 1. This is in standard form. If I look at this one, 6x to the third minus 2x, that's in standard form, right? So standard form means when you look at your variable expression, right, your exponents are in descending order. Now, the degree of a polynomial is the highest exponent in the polynomial, right? It's the exponent in the first term when it's written in standard form. So when I look at this one right here, this would be a degree 2. If I look at this polynomial written in standard form, the highest exponent on the variable expression is 4, so that would be a degree 4. The highest exponent in this expression is 3, so this would be a degree 3. And then the leading coefficient is the coefficient of the term with the highest degree when written in standard form. So the leading coefficient in this example would be that 3. Okay, it's the coefficient of the first term when it's written in standard form. The leading coefficient here would be 6. Okay? So now, just like number of terms, we name polynomials by degree also. The first one is degree 0. In a degree 0 polynomial, right, we call a constant, right? And it basically has no variable linked to it, right? So like we set up here, this 5 is a constant because it has no variable linked to it by multiplication. Degree 1, right, is basically called a linear, and that's when you just have x to the first, or you'll just see x. So 6x would be degree 1, which means that's a linear term. Degree 2 we call quadratic, and that's when you see the highest degree is being x to the second. Degree 3 we say is cubic, right? And that's when you see x to the third power. So degree 0, degree 1, degree 2, degree 3, right, are the four most common ones we use. Degree 4 we'll see, right, but a degree 4 is known as quartic, and that's when you have x to the fourth. Okay? So right now, we're going to go through some examples where we write it in standard form, and then we're going to name it by the number of terms. We're going to name it by the degree, and then determine the leading coefficient and stuff like that. So when I look at this, remember, if a term, right, is added, you know it's positive. If a term is subtracted, consider it to be negative. And always understand that we always look at the sign to the left of a term. Okay? So when I look at this first example here, 12x minus 10x squared plus 4, I'm going to look for my highest exponent first. And this has the highest exponent. Now, If I read this as negative 10x squared because this minus sign tells me it's negative 10x squared. I like to cross it out so I know I've used it. Then, since 12x is the next highest exponent, I know it's positive, so I'm going to add it. So plus 12x, cross it out, I've used it. And then my constant will always be the last term if there is one. Okay, so right now that is now written in standard form. How many terms does this have? If I look, there's 1, 2, 3 terms. And the name by terms then would be a trinomial. Now the degree. When we talk about the degree of this, I look for the highest exponent when written in standard form, and that's exponent 2. So the degree of this is 2, which means the name by the degree, right? If it's a degree 2 polynomial, I know it's going to be a quadratic. And if I look at the leading coefficient, the first term after it's written in standard form, that leading coefficient is negative 10. Okay? The next one, if I look, where am I going to start with this? What is the highest variable exponent? If I look, it's positive 8x to the third. So I'm going to write this as 8x to the third. Now I look, is there an x to the second? Yes. My x to the second is here. Since that's negative 2x to the second, I'm going to subtract it. Minus 2x to the second. Then I have my x term. Since it's the coefficient of that's negative 7, I'm going to subtract it. And then I have my constant as plus 5. So remember, the signs are just as important as, writing in descending order by exponent. If it's positive, we add it. If it's negative, we subtract it. How many terms does this have? This has 4 terms. And again, anything over 3 terms, we just call it a polynomial. The degree, the highest exponent is 3, so it's a degree 3, which means the name by degree is going to be cubic. And what's my leading coefficient? 8. Okay, so again, standard form is probably the most important part, and everything else is all about knowing the vocabulary when we're talking in class or you're reading the directions. So let's go through a couple of examples here. All right. So standard form for this one. Right here, you just have 1 term, so that's already in standard form. Since it only has 1 term, right, the name by number of terms would be a monomial. The degree, since there's no x term or variable expression, it's 0. And the name by degree would be a constant, meaning it's not going to change value. And the leading coefficient is just 6. Okay. Next one. If I look for my highest exponent, x to the second, so I'm going to write this as 6x to the second. Then I'm going to put my x term next since it's minus 3x, right? And that's negative 7, so I'm going to go minus 7. So now that has 3 terms, which makes it a trinomial. The degree is 2, and the name by degree would be quadratic. Now, the leading coefficient would be 6. Okay. Next one. A little more difficult, right? Highest exponent here is x to the 4th. If I look, I'm going to write that as negative 3x to the 4th, then minus 6x to the 3rd, plus 8x squared, then plus x plus 7. So now I'm in descending order by exponent. But now if I look, how many terms do I have here? I have 5 terms, which means this is just going to be a polynomial by number of terms. The degree, the highest exponent is 4, so it's a degree 4, which means this is going to be a quartic. And the leading coefficient is -3. Okay, so remember, the leading coefficient always comes from the first term when written in standard form. And then the last one here. If I look, x is my highest exponent, so it's 5x. Since that's -10, we're going to subtract it, so -10. There are two terms, so the name by terms is a binomial. The degree, since the highest exponent, we don't see it, but we know it's there, is degree 1. And the name by degree then would be linear. And the leading coefficient would be +5. Okay? So what is the difference between classifying a polynomial by degree and by the number of terms? When you classify it by degree, you're looking at the exponent, right? When you're doing it by number of terms, right, we're looking at the number of terms being added or subtracted. Okay, so this vocabulary, guys, is very crucial, right? Because when we're teaching in class, you need to know what we're talking about when we're speaking, okay? So go ahead, work on the homework, and let us know if you have any questions.